such as gaze, body movement, speech, and arousal to visualize and capture students' learning processes. So we're very excited to have him here to share with us on these 3 challenges that he has even summarized for us in his work in looking at multimodal learning analytics. And I'm just forgot to introduce myself. I'm Dr. Elizabeth Cole, and I'm part of the Asia Pacific APSCE Computer Support Collaborative Learning or Learning Sciences Special Interest Group. And so we are organizing this session. You can also give us feedback after this webinar, which will last for about an hour. So if you have any questions, there's a Q&A section in this Zoom. There's a Q&A. So please put your questions there and during the webinar or at the end, and then we will take questions as and when we find that it's relevant, but mostly at the end. Yeah. So without further ado, we will start. I invite Bertrand to share slides.
Great, thank you, Elizabeth. Let me organize my windows here. All right, there you go. So thank you for having me here. I'm very excited to be talking at this webinar. If you want to have a look at the slides, there's a link on the bottom right corner of that first slide and the QR code if you want to have a preview of what I'm going to talk about. So the talk is supposed to be around 45 minutes. I'm going to cover quite a bit of material. So this way you can get a sense of where I'm going with this. So yeah, today I want to talk about some of the research we've been doing using multimodal learning analytics and trying to use some of those methods in real-world environments and what are the types of challenges that we've run into. So here's a quick outline. First, I want to talk about why multimodal learning analytics. Why is that something that might be helpful in education, both for educational research and educational practice. Then I'll talk a little bit about results from basic research. So what are the types of findings you can get using multimodal learning analytics in a controlled environment? And then I'm going to talk about 3 challenges that we've run into doing more ecological research. So let me start with the motivation. So I don't know if anyone knows what this is. You can try to guess, by yourself. This is actually the state-of-the-art measurement tool in physics. This is the Large Hadron Collider at the CERN in Switzerland. And it's an amazing piece of technology where engineers have spent decades, trying to design this so that they could get very precise measurements of the behavior of particles. So they really invested time and effort into trying to get measures that could help them, do theory building and develop more interesting applications. In contrast, this is the state-of-the-art measurement tool in education. We still heavily use pen and paper tests, especially for high-stake tests, in particular in the US. There are obviously other methods, but by and large, this is sort of what we rely on to make decisions about, educational approaches. And it's a little bit of a problem, and to use a metaphor to explain why, I'm going to refer back to the pandemic. So it's a little bit like only looking at test results and seeing, who's testing positive or not. So you can get a sense of how the virus is spreading across the globe, but you're not going to get a very good sense of how the virus is operating, how it duplicates itself, and what are the mechanisms behind the pandemic. For that, you need to have a different type of tool. You need to have a microscope so that you can observe moment by moment what is the behavior of the virus. So Measuring learning processes, so studying how people learn versus how well they learn, is important because it really impacts everything else that we do in education. It impacts our ability to make sense of the actual test results. It impacts our ability to do theory building in research. It also impacts the kind of inventions we can design to support learning and teaching in different contexts. It also impacts the kind of data we can provide teachers to support the teaching practices. And it impacts understanding not just who is successful, but why and how people might be successful. And that refers back to this idea of epistemological pluralism, which basically says that everyone has a different learning trajectory, and you want to be able to personalize things or to adapt instruction based on how people learn, and so on and so forth. I'm assuming that I'm talking to an education crowd, so I think most people would agree with those points. And this idea of focusing more on process and less on achievement is not a new idea. Werner actually in 1937 was already making the case that we need to focus more on process. One thing that has changed, though, is that nowadays we have new technologies that can allow us to capture more fine-grained process data. And some of those technologies are multimodal sensors like eye trackers, motion sensors, emotion detection tools, and so on, so that you can capture pretty large data sets describing how people learn, in a very fine way, looking at that time series data. This is a definition of multimodal learning analytics that GPT gave to me. It's actually pretty reasonable. So multimodal learning analytics, or MMLA, refers to the use of multiple sources and types of data to analyze and improve learning outcome and experiences. Includes all kinds of data sources. And the goal is really to get a richer understanding of learners' needs, behavior, and outcomes, so that we can develop more effective learning experiences. And for me, this idea of capturing learning processes is really like looking at an elephant. Each of those data sources can inform you in a different way, right? So some data sources can give you a sense of what the trunk looks like, or the tail, or the legs, and so on. And combining them can give you a more holistic picture. And probably one of the most productive way of combining those data sets is also integrating traditional data sources like learning tests, using qualitative methods to also richly describe what the data is like, and also using hand-coded assessments where you have a particular ground truth that have been accepted in the learning sciences, for example. And I'll give you a couple of examples of what that might look like. So this is sort of the motivation for using multimodal learning analytics. It's really this idea that those kinds of tools can help us get more process data, and that can help us better understand students and develop more interesting interventions and support systems. So before I jump into the more ecological research, I wanted to give you a couple of examples of MMLA research from controlled study, which is something that we've done a lot, just so that you get a sense of what this looks like. So in my lab, we're very interested in social learning. So when people come together to learn as a group, social learning is interesting because it both supports learning, right? When students work together, they have to explain how they understand things to each other, which makes their knowledge visible. They also engage in transactive discourse, which means building on each other's ideas. It's also much more motivational, and students tend to work in communities which can support them as well. But the other advantage is that all of those behaviors that they have in social context also make learning processes visible, right? When they explain things, they're going to use not just their words, but also facial expressions. They're going to change the tone of their voice, their body postures, their gestures. They're going to look at different places. And all of those behaviors are things that we can capture using multimodal sensing. So here's an overview of different lines of work that we've done using different modalities and different methods, with some references of papers. I'm not going to go through all of this, but I'm going to pick one and try to go in more depth into one of those examples. So I want to talk a little bit more about using eye tracking and looking at a construct known as joint visual attention to better understand collaborative learning groups. So why joint visual attention, or JVA? JVA is really interesting because it's very heavily theoretically grounded. There's 30+ more years of work showing that joint attention is crucial for language learning in the early years. And this is how, young children learn language. They point at things, they establish joint attention with their caregiver. Caregiver realizes that the child is looking at a particular thing, says the words that refer to that things, and then the child makes that association between the object and the word. And that's the beginning of language learning. Turns out that adults engage in a similar process, but instead of learning words, we learn how others perceive and think about the world. And this is a process known as grounding in communication, which means that we try to build a common ground with the people that we work with, try to make sure that we refer to the same things and that we have the same understanding of particular task or concept. In collaborative learning, grounding is even more important because it reflects how groups build a shared problem space and collaboratively build knowledge. So it's a type of grounding that's continuously updated based on what people are learning in the moment. And turns out that joint visual attention is a really good proxy for this process of grounding communication and understanding. So we've done a lot of work trying to capture joint visual attention in a more quantitative way. I'm going to show you an example from a study on the next slide. I'm going to quickly pause. This is a task where we had a lot of pairs of students who are learning how to program this robot here, and they're using this block-based environment, and the robot had to navigate different kinds of mazes. So they basically had to learn programming. And they were wearing mobile eye trackers, so you can see their perspective here on the right side. This is on the top, the person on the left side, on the right, the person on the right side. And you can see their gazes in green and blue here. And we're leveraging those QR codes in the environment to be able to remap those gazes into this common image in the left here. So if you know those sets of points from one perspective, you can remap the gaze into a common perspective. And the whole point is that we can have the gazes of the two people on the same image. And then when they're close enough, we can say there is some joint visual attention going on, like the dots right now on the left side that are turning red here. And so that means that we can quantify this idea of this construct of joint visual attention, and we can study it in more rigorous ways. Hopefully that makes sense. And the fact that we can, quantify this helps us contribute to theory about JVA. So we've done different studies. In one of them, we found, or most of them actually, we found that levels of joint visual attention tend to be correlated with outcomes that we care about, for example, learning gains or collaboration quality. But it's not always true. We've also found that some groups had high levels of JVA and didn't necessarily do well. And what was interesting is that in one of those groups, one person was always initiating those moments of joint visual attention, and the other person was always following the gaze of the first person. So there was a more passive person who is also sometimes called a free rider. And that's something that we can detect using eye tracking data. We also found that high-performing groups engage in transactive discourse. This is what I mentioned earlier, where people build on each other's ideas, and joint visual attention tend to be correlated with how much people engage in transactive discourse. And finally, we've also found that high-performing groups tend to cycle through states of low and high joint visual attention more than low-performing groups. And I'm going to go into slightly more details on the next slide, because I think this is interesting, and this is our most recent paper that has just been published in Cognition and Instruction. So in this study, we were interested in better understanding what happens in a particular collaborative episode when those levels of joint visual attention are going up and down. So basically, we're able to generate those graphs for each group, and we're interested in trying to understand what explains those variations. And what we found is that when joint visual attention tend to go up, people tend to engage in collaborative behaviors, meaning that they're actively interacting with each other, they're looking at the same thing at the same time. And when joint visual attention goes down, they tend to engage into cooperative interactions, which means that they're working in parallel, they're not really interacting with each other, but they're still focused on the task. And we found that qualitatively that the groups that tended to be more successful went back and forth between those moments of cooperation and collaboration more than groups that were lower performing. And just to show you a couple of more precise results. So some of the outcome measures that we're using is, for example, hand-coded rating scheme where you rate the quality of collaboration between two people in the group. And we also had learning scores on the pre and post test. And so you can see that there are some significant correlations with collaboration quality, with joint visual attention. But then when you quantify those back and forth, how many times did those groups go back and forth between collaboration and cooperation, you find much stronger correlations, and you actually find significant correlations with learning gains as well. So this sort of shows that joint visual attention is interesting, but you can go beyond that. And there are actually behaviors that you can derive from the eye tracking data that can better explain why some groups did better at this task, basically. So this is one example of results that you can get from, in this case, eye tracking data that we've been working on. I could go through some other results, but I think that would be all too much. And I actually want to jump into the meat of this presentation, which is more about how do you actually use some of those tools in more naturalistic settings. And I want to talk about 3 challenges that we've run into with my group. There are more, but we actually have contributions for those 3 challenges. So I want to show you a couple of solutions and ideas that we've had to make progress on those things. So I want to talk about which metrics should people focus on when they look at multimodal data, how should they implement them in ecological settings, and then how can you actually share that data with learners and teachers to actually have an impact on practice. All right, so ecological research with MMLA, how can we impact practice? So the motivation is that there's been a lot of work in MMLA in controlled environments, but not so much in authentic spaces, right? So there's a lot of research findings that are interesting, but people haven't tried too much to translate those findings into real classrooms or real learning environments. So as those authors say, it's clear that this line of work has not reached its full capacity and that there's still a lot of opportunities in terms of using those multimodal data sources in real world settings. So the first question or the first challenge that I wanted to talk about is which metrics should we focus on, right? With so much data, finding good metrics is really like finding a needle in a haystack. There are just so many different options, so many different directions that you could follow. It's good to have a sense of, what are promising directions instead of wasting your time going in a dozen different directions. And it's a challenging task because you can always look at the literature, you can find some papers, but it's going to be very difficult to settle down on particular metrics because a lot of them tend to be anecdotal. They can be generated on a small data set. A lot of them are not replicated across different settings. They tend to be very context dependent. So for example, people might be looking at particular gestures that happen in a setting, and those gestures are going to be totally different for a different domain. For example, if you look at things at gesture across math or history. The metrics might be computed in different ways. They might be population specific. And sometimes you find a lot of papers on particular metrics because they're easy to generate. And they tend to be popular because it's cheap and easy to generate those metrics. So for the context of collaborative learning, we've actually conducted a literature review that's referenced here. But as part of this literature review, we've also designed a website that makes it a little bit easier to get an overview of the field. I'm going to see if I can zoom out. You can access this website at mmca.gsc.harvard.edu. And on this website, you can look at different aspects of collaboration. We've divided this into conditions for good collaboration, products that groups produce, and then processes that were captured in those different studies. And you have those different subdimensions. So for example, if you're interested in how people coordinate, you can click on this and you're going to see all the different metrics that people have used. So for example, you can look at electrodermal activity synchrony. You can click on the paper, and then that's going to open up in Google Scholar, and you can actually look at the paper and see how this was computed in this particular context. You can also click on, for example, I don't know, physiological data. You can look at the different metrics that have been used in this context. Again, you can look at the actual paper. And you can also click on the connection between, for example, learning and gaze, if that's something that's interesting to you. And then you can look at all of those different metrics that have been found to be significantly connected with learning gains. So this is a very alpha version of this website. We're actually currently redesigning it to have more tools, to have more ways of visualizing the data. But this is a sort of a first step of sharing the state of the field with, for example, newcomers or people who don't have time to actually survey the entire field to figure out what are some interesting metrics and how much evidence do we have between the connections of those metrics with those types of outcome measures and processes. So I encourage you to play with this website. Please send us some feedback if you have any suggestions or if there's anything that you feel like is missing. That would be really helpful for us. So in summary, this kind of platform, I think, can help us speed up implementation by helping people identify promising metrics, could inform predictive models, and like I said, make the state of the field more accessible to newcomers. It's pretty overwhelming to just go on Google Scholar, get the papers you can find on multimodal learning analytics and collaboration, but it's going to take you a very long time to figure out which metrics you might want to focus on. So we're working on the next iteration of this website. We're currently expanding the literature review to the last 2 to 3 decades. So we're going to have much more data. We're also working on adding filters so that, for example, you can decide to filter papers based on a population of interest. If you're interested in, younger adults or children or adults, or you could also filter the data based on context that you're interested in. So, for example, are you interested in, math education or typical classrooms, open-ended environments, and so on, so that you can better, select the kind of papers and metrics that could be helpful for your own context. One thing that we're currently thinking about and trying to add are links to computational notebooks to help you generate and compute those metrics so that you don't need to reinvent the wheel. You can use code that already exists, and you can generate those metrics a little bit more easily. And that's actually a segue into the next section. So the next challenge that we found is generating that data and computing the metrics is non-trivial, right? You need a lot of knowledge and resources to do it. So more specifically, usually research-grade wearables are intrusive and distracting. If you think about, mobile eye trackers, you have to wear this on your head. You're very aware that your gaze is being tracked. You need a technical know-how. Basically, you need a computer science degree to get the data and work with those APIs. And a lot of those sensors are actually pretty expensive. So, working on a larger scale, or if you don't have a lot of resources, that's probably something that would be pretty challenging. I've listed a couple of examples of sensors that we've used in our research and sort of what are like brackets of price for those kinds of sensors. So to help people more easily generate multimodal data, we've come up with another website that anyone can access at mmla.gsc.harvard.edu. And on this website, if you go on the tools page, there's basically a ton of data collection tools that most of them are web-based. And so you can extract data just with your browser. You don't need to install anything. You don't need to install libraries. You can just get data directly in your browser. I'm going to give you a quick demo using one of those models, the holistic model, which is pretty cool. It does hand tracking, body tracking, and face tracking all at the same time. Takes 1 sec to load. So this is face tracking, right? So it's going to capture all those key points in my face, but then it also does, full body tracking and hand tracking, and gives you the key points of all of the joints in your body and your hands. And on the website, you can do data collection. So I can click here, and that's going to start collect the data from my webcam. You can add tags. So let's say there's an interesting event that happened. I'm going to tag it. And then you can add one last tag to say, this is the end of my data collection session. And then you can stop things. It's going to give you an overview. And then you can actually download the predictions, which is the actual data set. And you can also download the video. You can also use most of those models by uploading a video and post-processing them. So if you have run studies and you need to extract data from those studies, you can do that after the fact as well. We have a lot of different tools. Let me see, there are some other examples. There are some simple eye trackers that are not perfectly accurate because it's using your webcam, but gives you a sense of where the person's gaze is. We have models that do heart rate detection as well. It's using those models that look at micro changes of the color of your skin and infers heart rate based on that, and so on and so forth. And recently, we've also added Google Colab notebooks for more complex and sophisticated models, where people can actually use the notebook, modify it in whatever way they want, and they can do like more custom operations on it. This is also a platform that we are currently updating and improving, and we're always adding more and more models. But basically, it's an easy way for people to do multimodal data collection. It's something that I've used in my classes with students who had no programming experience. And it's great because they can just go on the website, collect multimodal data, and then use some data visualization software to make sense of that data. So our goal with this is to create what constructionist people call the low threshold and high ceiling multimodal data collection toolkit, meaning that it's easy to use for everyone, but you can still do very complex and interesting things with it. Cool. So that's the second contribution and the second obstacle that we're trying to solve. So then let's say you've identified some promising metrics. You've been able to generate them using the MMLA website or different tools. But then how do you actually use that data to support learning and teaching? And that's the next point that I wanted to talk about. And I want to give you an example of an implementation of MMLA techniques in a constructionist learning environment. So we've done a lot of that research in makerspaces. And that's going to be the third point that I want to talk about. I'm going to take a quick breather. I see that there are some questions in the Q&A. Feel free to post your questions already, and I'll answer them at the end of the presentation. All right, so let's say we have some data, we have some metrics. How do we actually use them in real-world settings? Like how can we leverage them to help both teachers and students? This is actually an open-ended question. Like nobody has figured that out. There are interesting directions that could be followed, and I'm just going to show you a few of them that we've explored. So the context that we're interested in are makerspace type of environments. So makerspaces, to us, are really interesting because students engaged in project-based learning, they construct interesting artifacts, they identify problems in their communities, and they try to design innovative solutions to those problems. And they learn a lot of skills during those projects, right? They learn to iterate, they learn to work through various problems, and they learn to work in small teams. So there's a lot of interesting learning that happens there, especially in terms of 21st learning skills. So in our school, we have a makerspace here that's equipped with laser cutters, 3D printers, electronics, robotic toolkits, and so on. And we've equipped the makerspace with 8 different cameras that capture what happens in the space. So from those video recordings, we extract 2D pose data. And this is an example here. This is actually one of my PhD students who's just walking around the space. And we get that data from those 8 cameras in real time. So this is an example of the resulting data from those 8 different cameras. There are only 7 of them here, one is missing. But then we combine all of those 2D pose data into 3D poses. So we can actually tell where that person is in the space. And we can also tell what their body posture is because we have the 3D coordinate of all of those key points. And you can see on the bottom left, this is the 3D data that's been mapped onto a floor plan. So if I go back, you're going to see that person walk around the space. You can see that he's swinging his arms. So that's the 3D data here. And this is actually pretty accurate. It took us a very long time to get good, accurate data using this method, but now this is actually working actually pretty well. And we're also adding other pieces of information to that data. So we're also using models to infer gaze direction. So you can see here on the bottom left, there's a line of sight for each person. And for example, those 2 people here are working together. The line of sight is turning red, meaning that there is some joint visual attention. And that tells us that they're probably working together. This kind of gaze data is really interesting to us because a lot of learning that happens in the makerspace is observational. So people look at each other, they learn by modeling good behaviors, by modeling good problem-solving strategies, and being able to tell who's observing whom actually gives us a lot of information about how they're learning in that space, in that social context. So that's data that we're currently analyzing, trying to figure out, what to make of it. We're capturing data 24/7 over an entire semester, so it's a really big data set, takes a very long time to process. But we have some indicators that we know are interesting and useful. And we're trying to prototype good ways of sharing that data with teachers. So our first attempt that didn't really work was to have dashboards. So this is a page on the website that we have that shows the data to teachers and facilitators in the makerspace. So each row is a different student and each column is a different week in the semester. And so that already gives you some useful data, right? You can identify weeks where the workload is way too high, like this week here. You can also identify students during a particular week who are working way too much, who are spending too much time on their projects, which might be a good and a bad thing, but you might want to check on them. And you can identify weeks where maybe the workload is too low, where people don't have enough to do. So that can give you ideas in terms of improving the course and and better supporting students. The problem with dashboards is that people rarely look at them, right? It's like it takes extra work to go on this website, look at the data and figure out what to do with it. So because of that, we've tried to pivot to a different direction. At the same time, research recognizes that personalized and well-crafted feedback is crucial for learning. So we're like, maybe we can go in this direction, and instead of having a dashboard, we can help teachers craft more meaningful feedback from that data. So last semester, I taught a class in the makerspace, and we tested an email digest. So every week we would send out an email to both facilitators and students in the class. And we tried to use AI to help generate that feedback. So we used GPT before everyone was talking about GPT. And this is using an earlier version. It's GPT-3. So it's a little bit less sophisticated, but we still got some pretty interesting results. And for now, we're mostly working with self-reports, but soon we're trying to include more multimodal data for crafting the feedback. So let me show you what this looks like. I'm going to show you examples for facilitators and students. I'm going to start with facilitators because we had a simpler template for this email digest. It's basically a summary of, for example, how much time people spent on the assignment, what was their enjoyment level, stress level, and so on and so forth. The most useful thing that facilitators used on this feedback, on this email digest, was this. We had aligned with a little bit of logic saying, oh, you might want to pay attention to this student because he spent way too much time on the assignment. This one because they had low enjoyment, and some other students because they had a high stress. So right away, facilitators knew that, oh, I need to check on those people because they might be in trouble. For the students, we played around with GPT, trying to see if that could save some time and also write more comprehensive feedback. So this is an example of a blog post that students wrote. So every week they will document their project, they describe everything they've done, struggles that they had. And if you just plug this into GPT, you get this kind of feedback here, which is actually pretty good. So the feedback from GPT says that, oh, this is an interesting and imaginative project. I'm impressed by the level of details you're able to incorporate. Love the way you make it your own by adding, some particular details. I think you did a great job of staying calm and organized throughout the process, blah, 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 great work. So this is pretty good supporting feedback. Maybe not so great in terms of critiquing and suggesting, areas of improvement, but still a pretty good starting point. So this was encouraging to us. We're like, maybe we can use this in some ways. So we added a different page on the website, which looks like this. this was a very first iteration. We're actually moving away from this. But our first attempt was to have this kind of template here that we wrote by hand. And then we had different sections with different prompts to GPT. And those different prompts were defined below. We had some conditionals, for example, for students who had a lot of enjoyment, but high stress level as well. And that was a different prompt from students who reported different levels of enjoyment and stress, for example. I'm not going to go too much into the details, but the point is that we generated some of that feedback using GPT, using some of the data from the self-reports. That was then edited by the facilitators to make sure that they looked okay. So we made sure to have a human in the loop for this kind of feedback. And we also used it to summarize the work of other students so that they could more easily connect and they could be more aware of what was going on in the class. Again, this is very preliminary, but we also asked them about their sense of belonging in the class and burnout. And we had some initial results suggesting that people who received this personalized email compared to like a simpler version that wasn't using GPT, that was more standard, tended to have a higher sense of belonging. And they also reported to have a lower sense of burnout. So it's sort of encouraging. I think it shows that there is some potential in using large language models to try to personalize feedback a little bit more. And ultimately, our vision is that we can include more data sources, right? Not just the blog posts that students write and their self-report, but we can also incorporate a lot of sensor data and feed that into GPT as well to write feedback that would be much more comprehensive than what would be written by just a human. So we had some promising results with this, but we also had interesting challenges. One of them is that there are two, getting good input is sort of a different problem from getting a good output, right? Sensor data can be noisy, self-reports can be biased, and then the quality of the output is like a totally different project, right? For example, the dashboard didn't work, but the email digest seemed to work a lot better. Crafting good feedback is also more an art than a science. It was really difficult to get something that resonated with students. Took a lot of iterations to figure out the good prompts to use with GPT. And we also had issues that we were not able to solve. Oftentimes the feedback that was written tended to be repetitive. So if GPT would say the same things week after week, and it was difficult to make it like always very meaningful to students. All right, the next step, we're trying to revise the interface, make it more human-driven so that the feedback really starts with the facilitator's initial thoughts on the assignment, and so that it's a little bit less driven by the AI. All right, I'm running out of time. I want to make sure we have time for questions, so I'm going to do a quick summary and conclusion. So in summary, we're trying to build like a methodology and some type of pipeline to facilitate MMLA research and implementation, both for researchers and for practitioners. So we're really trying to help people do better metric selection by providing some kind of visualization that help them understand, what's the state of research, by providing tools that help them do data collection, providing examples of implementations in real-world settings, and then exploring how we can give feedback to teachers and learners using that data. So in summary, I think multimodal learning analytics has some potential in terms of maybe not better, but more holistically capturing learning processes. But to get there, we need better tools, infrastructures, synthesis of the field, recommendations for building good metrics. And we also need a larger critical mass of people using those tools so that people can help each other and there's some momentum going. Is that going to impact practice in the near future? Probably not. It's probably too early. To really see improvements, we're probably going to need iterations of applications that are co-designed with practitioners. So we need a lot more of design-based research where people try to implement those methods in real-world environments and work with teachers and students to figure out, relevant ways of using those data sources. But I think it really presents a lot of opportunities for designing new kinds of interventions and also providing formative feedback that's more process-based, that's not just based on outcomes. There are a lot of caveats to this type of research, and I'm listing quite a few of them on this slide. I'm happy to talk about any of those topics. There are a lot of, obstacles we have to overcome, but they can also be seen as opportunities. I think they can be really interesting ways of, contributing interesting things to that field of research. Running out of time, so I'm just going to finish by acknowledging the work of the many students and collaborators who worked on this project. None of this would have been possible, without them. And I'm very grateful to have the chance to work with all of those people. Thank you so much for your attention, and I'm very happy to take questions.
Thank you for that very inspiring talk. I think we have quite a number of questions, and I'm also very impressed by not only challenges, but also how your group and yourself have tried to tackle them. So we have a couple of questions in the Q&A as well as one chat. But I think some of them are quite related to the tools that you have developed. I think this is from Suraj R. He mentioned, I think this was the first tool that you shared, which is the MMCA website. He or she asked, is this open source? It's more of a website, so but
yeah, it's a website. We have a GitHub repo for the website. I don't remember if it's public or private, but we have the list of all of the papers on that website as well. For the second website, the EasyMLA website, we also link the source code of all of those models here. So, for example, if you look at Google Colab notebooks, at the beginning, there should be a link to the research paper and the repo so that you can actually, see where the model comes from. And similarly, I think for the JavaScript model, yeah, there's a link to the source. So if you have your own platform, you don't need to rely on our website. You can just use the code that's hosted on GitHub and develop your own applications.
Great. Thanks for that. I think the next set, Christine asked, thank you for the sharing. For the study on joint visual attention, you mentioned that the videos were hand-coded. May I know how it was done? Was the entire video coded or only certain segments or intervals?
Yeah, that's a great question. Feel free to look at the paper. So we're using this rating scheme that was developed by Meyer, Spada, and Rummel. It's a rating scheme that's been used a lot in CSCL and computer-supported collaborative learning. So you have all of those sub-dimensions that you rate for the entire collaborative episode. You can do it in a more fine-grained way as well. You can segment things into, 5 minutes or 10 minutes. But in our case, this was just to get an overview of how well people worked together. I encourage you to look at the paper. It's a great paper. It's a great tool. It's sometimes a little bit tricky to get good interjudge reliability. So you have to make sure that the people who are coding the videos are on the same page and understand those dimensions in similar ways.
Okay. I think the next set of questions are some larger questions. I think Shenba asked, the tools look impressive for research purpose. How can we argue that the data collected with these tools are accurate?
Yeah, that's a great question. They're not. A lot of those tools have limitations, and you have to be aware of those limitations. So, for example, a lot of the tools that we have on the website are open source, and they've been trained on different data sets. So in one of my class, we had people use the emotion detection tools from facial expressions, and we realized that those tools were not working well on, for example, African American people, because the data set that they used to train the model was from Caucasian people. So it's always really important to test out those models and check what the data that they was trained on looks like. And also understand that there are some hardware limitations. So for example, if you want to do really good eye tracking, you need, infrared cameras, you need like professional eye trackers. If you use webcam-based eye tracking, it's going to give you a rough sense of where people are looking at, but it's not going to be perfectly accurate. Yeah, I mean, each of those tools have limitations. Like pose data can be very, very noisy as well. So you always want to have a step where you sanity check your data after the fact, where you visualize it in some ways to make sure that your data is not off or that it's not biased or full of noise or outliers in some ways.
Yeah, it's definitely important sanity check. Yes. Yeah, thanks, Bertrand. So the next question is about Justina Hughes asking about, first she thanks you for the inspiring talk, and she wants your opinion on the use of MMLA, which incorporates immersive virtual reality in teaching. Incorporate immersive virtual reality in teaching.
Yeah, that's super interesting. I think that's a really fruitful area of research, because in virtual reality, you have a lot of those sensors that are integrated into the headsets. So there are some VR headsets with eye tracking, with EEG sensors, and so on. So it's not as intrusive because it's part of the environment. We haven't done research on VR, actually. We've done a lot of work with augmented reality, trying to use those tools in makerspaces again. But AR is quite different from VR. So I would need to know a bit more about your context and what exactly you're interested in terms of VR. But I think it's a great question. It's a great area of research. I don't know if you can follow up in the chat or somewhere.
Yeah, or perhaps an email later down the road. Yeah. Yeah, thanks for that. The next question is about when you looked at the study on belongingness, Setu asked, what metrics have you used to measure belongingness and burnout?
Yeah, really good question. A lot of times we have to rely on self-reports. So in this particular case, we had surveys. So we tried to use, surveys with valid psychometric properties to make sure that they capture what we want to capture in, a pretty reliable way and valid way. But, as we all know, surveys have limitations as well. But this is sort of the best ground truth that we have access to. Yeah, and I can share. I would have to look it up. I don't remember exactly which surveys, but there are a lot of them that exist out there. And we probably tried to use like a short version to not take too much time from all students. You can follow up with me by email. I can find out which of the surveys we used, if that's helpful.
Great, thanks. Okay, we have this question that is about okay, this is asked by Xian Jun Chen. He or she asked, could you address the issues of equity and technological over-expectations? Issues of equity and technological over-expectations.
That's a very broad question. I'm not sure about equity. So technological over expectations, for sure, that always happens with any technology that's being used, especially in education. That's why I try to also be a little bit more skeptical. And also at the end of my talk, I was trying to adjust people's expectations. You're not going to change education by using those tools, but I think there are particular contexts where you can make small differences that can be helpful for teachers and learners. I think that those technologies can also help address or make issues of equity worse. Like, it can go both ways. It really depends how you use them. Can make them make those issues worse if, only students from, affluent schools have access to those tools and, who can receive support, like the ones that I've described. But it can also make things better by revealing, issues of diversity, equity, and inclusion. So something we've been also looking at through the data in the makerspace is to highlight facilitators' preferences, right? We all have preferences in terms of who we want to help. We tend to converge toward people who look like us, think like us, and so on. And we have this, implicit bias. And not all the teachers and facilitators are aware of it, but I think it could be helpful to reveal those biases using concrete data, where they could be like, oh yeah, oh my God, I'm not paying as much attention to those students, and they probably need my help as much as other students. So I think there are opportunities in terms of making those biases visible so that teachers can, improve their own practices.
Yeah, thanks for that. Definitely make it visible to and for the purpose of improving. Yeah, that definitely, I hope, addresses the questions. Yeah, the next two questions are a bit more specific, which I think, Bertrand, you can just inform them directly. And I had a question which is related to more, because the first set of questions project you looked at were in the lab-based and they were dyadic collaboration. Mm-hmm. And I know you're trying to move on to more than 2 persons. Ida, what's your, so far, how have you progressed to looking at more than 2-person kind of collaborations for looking at and the different metrics related to that?
Yeah, I don't know if I have a good response to this because it's a very difficult problem, right? When you have 2 people, it's like really easy to know that, they're interacting with each other or not. But then if you have more than 2, like who is actually interacting with whom, that's very difficult to tell from the data. But I think, like I said, an angle that's really interesting to us is to look at who observe whom's, right, in a space, this idea of observational learning. So you don't necessarily need to know exactly who is interacting like explicitly with another person, but you can see who's paying attention to, other people in the space. And then you can also look at the data and see if people are repeating the behaviors that they're observing, which can be indicative of learning. So I think you have to find those proxies that can tell you that, some type of learning happened. And instead of, necessarily going into like larger entities or larger like analysis of larger groups, because that might be a little bit more difficult. Anyway, the summary is that I don't have a good answer for you. It's it's a tricky question. Yes, if you have suggestions, please send them my way.
Yeah, I think it's something that as a research community, we're all trying to tackle one step at a time. Yeah. So actually, this brings us to the end of this webinar. I think one of our colleagues will show the feedback slide to give you some feedback, to ask our participants to give some feedback. And there are 2 questions on the chat, which maybe, Bertrand, could you just answer, type the answer, because it's quite specific. Long-San, will you be showing your slides of the feedback? And there's some announcements about the next webinar. Yeah, but thanks again, Bertrand, for your really impressive presentation. I think I totally agree with the 3 challenges and how they are. We need to tackle those ideas of metrics, how is it going to be in the real world. So this is the announcement for the next webinar that's coming up, organized by APS, Asia Pacific Society for Community Education, another SIG. Yeah, so it's on 16 June about smart technologies. And the next slide is the feedback. Yeah. So please take some time to give us some feedback. And you're also invited to join our SIG. Actually, it's the link is actually on APSCE, that website that you see there. So you can also join the SIG. Basically, we send emails and we try to organize community building events. Yeah, so I guess this brings us to the end of the webinar. Thank you so much for your questions and so forth. Bertrand, who has shared with us such insights from his work. Yeah, so this brings us to the close. So we can, I guess, stop the recording, and thank you everyone for coming this day or night, wherever you are.
Thank you for having me. Bye-bye.